All right, let's talk about one of the most useful tools you're going to have for differential equations, separable equations. We're going to see how you can take a problem that looks really complex and just turn it into a simple sorting exercise. Let's get right into it.
So you've seen these before, right? In your homework on exams, these equations with x's, y's, and derivatives all jumbled together. They can look pretty intimidating. But what if I told you that for a whole bunch of these problems, the secret is just putting all the y stuff on one side and all the x stuff on the other? Well, it's true. It's often that simple.
So, first things first, how do we even know we're looking at one of these separable equations? Let's define what we're hunting for. Okay, here's the textbook definition. A separable equation is any differential equation you can shuffle around with algebra to get it into this form. Now, don't let the n of y and m of x stuff scare you. It just means you have some function of y, could be anything with a y in it, times dy on one side, and on the other side, some function of x times dx. The main idea? If you can get the variables sorted, it's separable. That's it. And you know what the best part is? There's a totally reliable 3-step game plan for solving these every single time. Let's go through it. It really is this simple. First, you separate. This is where you do the algebra, right? Get your y's and dy on the left, your x's and dx on the right. Step 2, you integrate. Just integrate both sides. And finally, step 3, you solve. This is where you use any initial conditions they gave you to find your constant, and you clean everything up to get your answer. Just remember, separate, integrate, solve. That's your new mantra.
Okay, theory is one thing, but let's actually see this recipe in action. We're going to run through a couple of real examples so you can see how this works step by step.
So let's try out our 3-step plan with this first example. We've got our equation and we have an initial condition. That little piece of info is going to let us find the one specific solution that works. First up, step 1, separate. Remember, y prime is just dy over dx. So to get all the y terms on the left, we're going to divide by y squared. And to get the x terms on the right, we'll multiply by dx. And boom, just like that, we get this perfectly separated equation you see here. Now for step 2, integrate. We're going to integrate both sides. So the integral of 1 over y squared, well, that's y to the negative 2, which becomes negative 1 over y. Easy enough. The integral of 6x is 3x squared. And this is super, super important. The second you're done integrating, you slap on that plus c, the constant of integration. You only need one, and we usually just stick it on the x side. And last but not least, step 3, solve. We're going to use that initial condition, y of 1 equals 1 over 25. So we plug in 1 for x and 1 over 25 for y. That lets us figure out that c is negative 28. Then we just plug that value for c back into our equation and do a little algebra to get y by itself. And there's our final answer, an explicit solution. All right, on to example number 2. This one looks a little more involved, but don't sweat it. The process is exactly the same. But pay close attention to what the final answer looks like this time. Okay, let's speedrun this a bit and do steps 1 and 2 together. We just cross-multiply to separate the variables. Then we integrate both sides. The left side becomes y squared minus 4y, and the right side becomes x cubed plus 2x squared minus 4x, plus our old pal, c. And now for step 3. We plug in our initial condition. X is 1 and y is 3. Do a little arithmetic, and it turns out that c is negative 2. Now look at that final answer. We could try to solve for y, but it'd be a huge mess with the quadratic formula and all that. So we just leave it. This is totally okay, and it's called an implicit solution. And this is a perfect way to show the two kinds of answers you'll get. An explicit solution, like in our first problem, is when you get y all by itself. Y equals some function of x. An implicit solution, like the one we just did, doesn't give you y directly. It just shows the relationship between x and y. Honestly, unless your professor specifically tells you to solve for y, the implicit answer is usually the cleaner, better way to leave it. Okay, one last example. This one has a little trick to it. When you first look at e to the x minus y, you might think, hey, that's not separable, but a simple exponent rule is all you need to crack it. Here's the key. Remember that e to the power of x minus y is the exact same thing as e to the x divided by e to the y. The moment you see that, the path forward is obvious. We can easily separate it into e to the y dy equals e to the x dx. Integrating both sides is a piece of cake, which gives us e to the y equals e to the x plus c. And to finish this one off, we just need to get y by itself. We can do that by taking the natural log of both sides. And there you go. Our final explicit solution is y equals the natural log of e to the x plus c. So we've seen how to do these problems the right way. Now let's talk about the single biggest mistake students make:
Seriously, if you remember nothing else from this explainer, remember this next part.
Forgetting the plus c. You absolutely have to add it the instant you finish integrating. If you forget it, or if you wait and try to plug in your initial condition before you add it, you will get the wrong answer every single time. It's the most common mistake, and it's so easy to avoid. So burn it into your brain, integrate, then immediately write plus c.
All right, we've got the method down. Let's zoom out for a second and talk about why this is such a big deal in your calculus journey.
So let's boil it all down. What are the absolute must-knows? 1. Separable equations are all about sorting your variables. 2. Your game plan is always the same. Separate, integrate, solve. 3. Don't you dare forget that plus c right after you integrate. And 4. Sometimes an implicit answer is not just okay, it's the best answer.
Look, learning how to solve separable equations is more than just checking a box in your calculus class. This is a foundational skill. It's the technique behind modeling all sorts of real-world things, from how populations grow to how chemical reactions happen. So as you move forward, think about this. Now that you've got this powerful tool, what other tougher problems are you ready to take on?